my channel. In today's video, we'll see how to complete this challenge lab, implement DevOps workflows in Google Cloud. So this challenge lab has been updated. Here the task 3 has been updated. In this challenge lab, they have introduced the GitHub. So in my old video, the task 3 was different. There we were using the GCP repository, but now they have introduced a GitHub. A few of you have commented that you are facing issues completing this task 3. That's why I have created a new video with the updated lab steps. So in this challenge lab, we'll be creating a JKE cluster based on set of configurations provided. Then we'll be creating a GitHub repository to host our Go application code. Then we'll create a cloud build triggers that will deploy a production and development application. Then we'll be pushing these updates to the app and creating new builds. As a final task, we'll roll back the production deployment. So let's start the lab. I'm in console now. Let's activate the Cloud Shell. In task 1, we need to create the lab resources. So here we will be enabling the APIs. Here gcloud services enable. We are passing the services name here. The container and the cloud build service APIs we are enabling here. So this is required because we'll be making use of this service in the upcoming task. That's why we have to enable these APIs to use that service. So let's copy this command. This is finished successfully. Next we will be adding the Kubernetes developer role for the cloud build service account. So first we'll export the project ID. We'll be setting the environment variable here. First we will export the project ID. So this gcloud config get value project will get the project ID and it will export it as a project ID variable. Next, gcloud projects add IAM policy binding. So whenever we are assigning any role to a service account, we need to use this IAM policy binding. So we are passing the project ID here and the service account name and what role we are assigning it to the service account. So let's copy this. Now this is complete. I will open this in new window. Next we need to run the following commands to configure Git and GitHub in Cloud Shell. So this will configure the GitHub in Cloud Shell. So these are the commands which we need to execute. So let's copy this command. Back to Cloud Shell here. So here it will ask where do you use GitHub. You can just enter. What is your preferred protocol for Git operations on this host? I will be using HTTPS. So here you can type yes, log in with a web browser or paste an authentication token. So I will be login with a web browser. Click on this link, it will take you to this login. I have created an GitHub account with this username. So it is taking that ID here. So click on continue. If you have not created account in GitHub, you can refer to my video. I have made a video on that, especially for this lab. So you can just go and check on that how to sign up. So the code which you get here, copy this code and provide it here. Then you can click on continue. Here you need to click on authorize GitHub. So now device is connected. Logged in as Soumya. So with this username I had created the GitHub account. So once this is done, you can clear the screen. You can go back. So this output you should get. I have successfully logged in. That's why I got my username as an output. So you should get that authentication successful message. You will get that message only if you have an active account in GitHub. So ensure you create an account in GitHub. It is free for use, so you don't have to worry about that. Next, create an artifact registry Docker repository name my repository in the US East 1 region to store your container images. So for that, you can refer to this link. This link contains all the steps which is required to complete this challenge lab. So first let's set the environment variables. So here I will be exporting the region. So in my lab I got US East 1, so I'll be exporting this region and the zone and the cluster name. So the cluster will be creating the cluster in the upcoming task. So let me copy this. So now it's done. Once that is done, we need to create an artifact registry Docker repository named my repository in the US East 1 region to store the container images. So that's the first task. So here we'll be creating artifact registry Docker repository by the name my repository. For that we need to execute this command gcloud artifact repository create. Since we are creating, we need to pass this create flag and the repository name. Since we are creating a Docker repository, we need to specify the repository format as Docker, and we need to pass a location in where this repository needs to be created. So description you can provide it or you can leave it, that is not an issue. So you can just copy this. Now the repository is created. Once that is done, we need to create a GKE standard cluster by the name Hello cluster with this configuration. So here the zone is US East 1-C and release channel is regular. Cluster version we should use 1.29 or the newer, and we need to enable the auto scaler. Number of nodes should be 3, minimum node should be 2 and maximum node should be 6. So if you want to list the repository, you can execute this command gcloud artifact repository list. It will list the created repository there. So I won't be executing that. Next, let's create a GKE standard cluster. So to create a cluster from the CLI, we need to execute this command gcloud container clusters create. Here I am passing the cluster name environment variable, so it will pick the value from this. Then zone is very important. You need to specify the zone, and the release channel I am giving it as regular. Cluster version you need to specify it as 1.29, and we need to enable the auto scaling. So we need to pass this enable flag here. Number of nodes should be 3, minimum node should be 2, max node should be 6, and we are enabling the IP alias. So let's copy this. So in my whole video I have shown you how to create a cluster from the console, so you can refer to that if you want to know how to create it from the console instead of CLI. So let's copy this command. And now the cluster is created. You should get this message. Once a cluster is created, you get this details about this cluster and the status should be in the running. Post that, we need to create a prod and dev namespace on the cluster. So before creating namespace, we need to connect to the cluster by executing this command gcloud container clusters get credential hello cluster. It's the cluster name. So this will update the config on the Cloud Shell. So this is very important. Before creating namespace, you need to execute this command. Before executing this command, ensure that you update your project ID. So this is a project ID which I got in my lab. You ensure that you update this project ID with whatever value you get in your lab. And don't just copy paste like that. You need to update few of the values like zone, project ID and all. So you should get this message kubeconfig entry generated for hello cluster. So now we are connected to this cluster. Next we can create namespace. So kubectl create namespace prod. So this is a namespace name prod and dev. So we are creating two namespace here. So let's copy this command. Now both the namespaces are created. So this is complete now. Let's proceed with task 2. Create a repository in GitHub repository. In this task, you create a repository sample app in GitHub repository and initialize it with some sample code. This repository holds your Go application code and be the primary source for triggering builds. So create an empty repository named sample app in GitHub repository. Clone the sample app GitHub repository in Cloud Shell. Use the following command to copy the sample code into your sample app directory. So let's perform this operation. First we need to create the sample app repository in GitHub. For this you need to log into GitHub with your account. If you already have an account in GitHub, you can log into that. Here I'll be creating a repository by this name sample app, and this will be a public repository. You just have to provide a name here. Click on create a new repository. Once this is done, we need to clone this repository on the Cloud Shell. So copy this URL. If you are using SSH, you can select SSH and copy this link git clone followed by the URL. We are getting you appear to have cloned an empty repository because our repository does not contain any code yet. So if I do ls, here we can find that sample-app directory. So let's cd into this, do ls here. There is nothing inside this. I came out of the directory because I will be copying sample code into that directory by executing this command gsutil cp-r. So this is the in storage bucket we have the sample code. From there we are copying the code to the sample-app. So let's copy this, go to Cloud Shell. Now the operation is complete. So if we cd to sample app, if we do ls, now we have few files in this. So we have copied the sample files into this directory. Next, we need to run the following command, which will automatically replace the region and zone placeholders in cloudbuild-dev.yaml and cloudbuild.yaml files with the assigned region and zone of the project. So we need to replace the region and zone in these two files. So for that, before making any changes, let's first see what contents it is having. Here you can see it is not updated, the zone is not updated, region is not updated. So this is how the file looks currently. Now let's cat the second file, cloudbuild.yaml. So this is also same, the zone region is not updated. So let's copy this command, go back to Cloud Shell, execute it here. We have to be outside of this directory to execute this command. So now we didn't get any issue there. If we cat, now if we cat that file, you can see the zone and the region is updated. So the region and the zone is updated. So again if I cat, here as well you can see the zone and the region values are updated. So now we have completed that as well. Next, create a GitHub repository with name sample app. So we have already created that GitHub repository. After creating repository, make your first commit with a sample code, add it to your sample app directory and push the changes to the master branch. Create a branch named dev, make a commit with a sample code, add it to your sample app directory and push the changes to the dev branch. Verify you have the sample code and branches stored in the GitHub repository. The code you just cloned contains a simple Go application that has two entry points, red and blue. Each displays a simple colored square on the web page depending on the entry point you go to. So let's do that. We have already added. So I'm not inside my directory. So now I'm inside sample app. So if we execute git status here, you can find there are few files. These are untracked files. We have not added these files yet. So first we need to add these files by executing this command git add. Next again if we run the git status, it shows changes to be committed. So all these files have been added. Now we need to commit this file. To the local repository. Further, I will be executing this command git commit -m, adding sample code. Now it's added. Now we have committed these files into the local. Next we need to push this into the remote repository. See, if I take you to the sample code, if I refresh, see it is still not having the code because our changes are still on the local. We need to push this. So now when you run git branch -a, it shows the master branch. Now let's execute this command git push -u origin master. So now we have pushed the changes to the master branch. If we go back here, let me refresh this. So now you can see this sample app. This is the repository. This was empty before. Now I have pushed the changes to this repository. We have only master branch here. So let's create a dev branch now. Next we need to create a branch named dev, make a commit with a sample code, add it to a sample app directory and push the changes to the dev branch. Since we have already pushed the changes to the master branch, we don't have any other changes to be pushed. So what we do is we just create a dev branch and push it to the remote. So for that we'll be executing this. To create the dev branch, we need to execute this command git checkout -b dev. So this will create a dev branch and we'll be pushing this. Let's copy this command. When I refresh this, if I click on this, so here you can find there are two branches now, master and dev. So if I click on dev, it also shows the all this code. So whatever code I push to the master branch, this dev branch is having the same code. So in this section, we'll be creating two cloud build triggers. The first trigger listens for changes on the master branch and builds a Docker image of your application, pushes it to Google Artifact Registry and deploys the latest version of the image to the prod namespace in your GK cluster. The second trigger listens for changes on the dev branch and build a Docker image of your application and push it to Google Artifact Registry and deploy the latest version of the image to dev namespace on the GK cluster. Let's create a cloud build trigger named sample app prod deploy that with the following configuration. Event should be pushed to a branch and sources connect to new repository and select the source code management provider GitHub. Choose the GitHub repository. Let's search for cloud build. You can click on cloud build here. So we are under cloud build dashboard now. Click on triggers. Click on create trigger. Copy this name. So you can select the region here. It will be US East 1. The event will be pushed to a branch. Post that. Under source repository generation, here you need to select connect new repository. Here you need to select GitHub. Click on continue. So you need to authenticate here. Click on authorize cloud build. Now it is authenticated. So you should get this blue check mark. After that, under select a repository, you need to click on this GitHub account and click on add. Install Google Cloud Build, install on your personal account. So you can select all repository if you want to connect all repository here, or you can click on only selected repository. Under drop down, select your repository. So this is the repository I created, sample app. I'll be connecting only this sample app repository. You can click on install. So now this is added. This GitHub account is added and the repository will be it will show only one repository because there I have selected only one repo. If you want to edit the repository, you can click on edit and add few other repository. But for this lab, we are doing only the sample app repository. We are concentrating only on one repository. So you just ensure that you select the correct repository here. Click on OK here, then you need to click on I understand. Then click on connect. See, now we are connected to the repository. So the branch will be master, configuration, it will be cloud build configuration file. You need to select this. By default it would have been selected auto detected, but you need to ensure you select cloud build configuration file, and here you need to provide that name cloudbuild.yaml. So service account you can select this. Okay, once done you can click on create. So now we have created one trigger here. Now let's create a second trigger, sample app dev deploy. So let's copy this name, go back here, click on create trigger, give the name here. Region will be US East 1, event will be pushed to a branch, and the repository we have already configured. So it's a one time. If we configure it, it will be available for other triggers as well. Only under branch you have to ensure. So if you remove that, it will list the available branches here. You need to select dev branch, then configuration, select cloud build configuration and a YAML. Let's copy this back here, provide it here. Service account, select this one, click on create. Now we have created both the triggers. So now you can click on check my progress. This should be complete. So we have completed the task 3 as well. Next, let's proceed with task 4. Deploy the first versions of the application. In this section, you build the first version of the production application and the development application. Build the first development deployment in Cloud Shell. Inspect the cloud build-dev.yaml file located in the sample app directory to see the steps in the build process. In cloud build-dev.yaml file, replace the version on lines 9 and 13 with v1.0. Then we need to navigate to dev deployment.yaml file and update the to-do on line 17 with the correct container image name. Also replace the project ID variable with actual project ID in the container image name. So I will click on open editor here. Click on open home directory. So here you need to click on sample app. So this is that file. On line 9 and 13 we need to update the version with v1.0. So let's copy this. So this we need to update version, and line 13 we need to update it here. Just save this file. Navigate to dev deployment.yaml file and update the to-do on line 17 with the correct container image name. Also replace the project ID variable with actual project ID in the container image name. So for that, under cloud build-dev.yaml file we can find the container image name. So this is the one. So let's copy this and go to dev deployment.yaml. So here you need to update it, and project ID, this also we need to update. So project ID we will get it from the lab only. So go back, copy that and update it here. Save this. So post that, make sure you have same container image name in dev deployment.yaml and cloud build-dev.yaml file. So in both the files we are having the same image. Next we need to make a commit with your changes on dev branch and push changes to trigger the sample app dev deploy build job. So let's execute this command git branch -a. Let's execute git status. So you have to ensure that you are on dev branch because we are doing this dev deployment. So whatever changes we are doing, we have to make it from the dev branch. So under when we execute git status, we can find there are two files which has been modified. So this is not yet added. So let's do git add. Again you can execute git status. Now you can see the changes to be committed. So this file needs to be committed now. Execute git commit -m. So you can give some meaningful name here. Once done, you can execute this command git push. So you should push it to the dev branch only. To this remote URL, we push the changes to the dev branch. So we have completed this step. Make a commit with your changes on dev branch and push changes to trigger the sample app dev deploy build job. Once that is done, verify builds executed successfully in cloud build history page and verify the development deployment application was deployed into the dev namespace of the cluster. So under history you can find this build. So this was successful. You can click on build. So build summary. So here you can see this is a trigger which caused this build. Sample app dev deploy. So there was a commit made onto the dev branch which triggered this build. This build was successful. Next we need to verify this. Kubernetes, you can click on clusters here. You can click on workloads here. So under workloads you can find this development deployment. This was successful. Status is OK and the namespace is dev. There are 3 pods and the cluster is hello cluster. This way you can verify it. Suppose that we will be exposing the development deployment to a load balancer service with the name dev deployment service on port 8080 and set the target port of the container to the one specified in the Docker file. So for that we need to execute this command kubectl expose deployment development -deployment. So this is a deployment name. We are exposing this deployment to a load balancer and the service name is this dev-deployment -service and the port is 8080 and the target port will be 8080 which is defined in the Docker file and the namespace we are specifying it as dev. So on dev namespace we are doing this. So let's execute this command. So now we can see the service is exposed. Now we need to verify the application by executing this command kubectl get service dev deployment service -n dev. So let's copy this command, go back to Cloud Shell, execute it here. So external IP we got it here. So we need to execute command something like this: HTTP followed by the external IP address of the load balancer, followed by the port number, followed by blue. Copy this in a browser, 8080 blue. You should get this output. Next, build the first production deployment. Switch to master branch. Inspect the cloudbuild.yaml file located in the sample app directory to see the steps in the build process. In cloudbuild.yaml file, replace the versions on line 11 and 16 with version 1.0. Navigate to prod deployment YAML file and update the to-do on line 17 with the correct container image name. Also replace the project ID variable with actual project ID in the container image name. So the steps are same for production deployment as well. So let's do that. So I will open my editor here. This time the file will be cloudbuild.yaml. Here we need to update the version to v1.0. So once you update this, you can save this and copy this container image name, and you need to go to prod deployment.yaml file. Here under to do, under line number 17, you need to update this. Okay, there are two files which needs to be modified. One is under prod namespace deployment.yaml file, line number 17, update the image name. So that image name you can get it from cloudbuild.yaml file and line number 11. So once this is done, so we should be on master branch. For that, you can execute this command git checkout master. Switch to master branch. Now execute this command git status. So here you can find there are two files in modified state. So we have to ensure that you switch to the master branch and make the commits. So let's do git add git commit -m updated YAML files. Then you can execute git push. So you should get this message. Now let's go back. We'll go to the cloud build. Here you can see the build pipeline is getting executed, and the ref you can see it is a master. So since we made changes to the master branch, so this trigger has identified it and it is triggering the build. So now this build is successful. You can go back. So we have two builds here. One is for dev branch and one is for the master branch. Let's go back to Kubernetes. Click on workloads. Okay, so there is an issue with this because I have not updated the project ID. That's why this build is failing. So let me correct that again. So what we have to do is, that's why you should not miss any step in this. So here under deployment.yaml file under prod, so this is a prod namespace. Here I didn't update the project ID, so this was missing. That's why that the deployment failed. So let's copy this, go back to Cloud Shell. So copy that project ID. So next save this. Let me clear the screen. Next, so let me add this quickly. So let me push these changes. So this time it should work. So in cloud build we can see there is one more build which got triggered and it is successful now. So let's go to cluster now. So let's refresh this. Now this deployment should be successful. So now you can see the status is okay. Earlier this production deployment failed because I didn't update the project ID. So I have to ensure that you update that. So now this is successful. Next we need to expose this production deployment. So we need to execute this command kubectl expose deployment. This time the deployment name will be production-deployment. We need to select this production deployment. Then the service name will be changed to prod-deployment-service, and the port and target port will be 8080 and the namespace will be prod. So let's execute this command. Now the service is exposed. You need to execute this command kubectl get service followed by the service name and the namespace. So copy this in a browser, paste that IP address. So you should get this output. Now even the prod deployment is successful. So you can click on check my progress. This should be complete now. So this is complete. Let's proceed with task 5. Deploy the second versions of the application. Switch back to the dev branch. In the main.go file, update the main function to the following. Add the following function inside of the main go file. Inspect the cloud build dev YAML file to see the steps in the build process. Update the version of the Docker image to v2.0. So let's perform this operation as well. Need to execute git checkout dev. So now we are switched back to dev branch. In main.go, copy this line alone. Only this is new, that's why I have added only that. Next, copy this. After this function blue handler function, we need to add a red handler function. So this is done. So once this is done, let's go here. We need to update to 2.0, 2.0, and under dev here as well we need to update it to version 2.0. So save this file. So execute git status. Now we have updated 3 files: cloud build-dev.yaml, dev deployment.yaml, main.go. So let's do git add, git commit, git push. Now the push is successful. Let's go to build history. So here you can see this build pipeline is executing. Now this is successful. So let's execute this command again and get the external IP. So here we need to give it as like this: external IP address followed by port number /red. So we are getting this output. So this is done. Next let's build the second production deployment. So let's go back to Cloud Shell here. Git checkout master. So now we are in the master branch. So deployment.yaml file we will update to version 2.0. Then cloud build.yaml, line number 11 and line number 16 we are updating the version number to v2.0. Then later we will come to main.go, and here under handler function we are just adding this line http.handle function. Post that, we'll add this, save this. So we can run git status again, git add, git commit, git push. So we can go back to build history here again. You can refresh this. This build is getting executed now. So now this is successful. So let's copy this external IP. So we need to execute this way. Now this is also successful. So you can scroll down and click on check my progress. This should be complete now. So this is complete now. Let's proceed with tasks. Roll back the production deployment. So roll back the production deployment to use the version 1.0 version of the application. Navigate to load balancer. So let's do that. We can go to build history here. So this was the one which we executed. So you can click on this build. You can click on rebuild. This contains version 1. Now this is successful. So this is the IP address which we copied. So if we hit this IP address again, so you shall get this message 404 page not found. So this is the IP address for the production deployment. So this is 134.23.94227. So if we hit this URL again, we should get this message 404 page not found, because we have rolled back to the previous version version 1.0 which contains that blue code. So if we give blue here, it will show that. So this is how we roll back it. So if you click on check my progress, this should be complete now. So we have successfully completed all the tasks in this lab. If you face any difficulties completing any of this task, you can update in the comment section. I'll be happy to help. Once you complete all the tasks in this lab, you can click on end lab. I will be sharing the GitHub link under the video description for you to refer. I hope you will be able to complete this challenge lab without any issue. If you found my video helpful, please like and subscribe to my channel and stay up to date with the latest content on this channel. Thank you all for watching. See you in the next video.